Welcome to your Algebra 2 Capstone Lesson 4 on fractional expressions. Quotients of algebraic expressions are fractional expressions. A quotient of two polynomials in particular is often called a rational expression. A fraction is in lowest terms if its numerator and denominator have no common fractions, in other words, are relatively prime. To cancel a fraction in lowest terms, factor the numerator and denominator and cancel common factors. All right, we're going to express the fraction in lowest terms, and we've got x squared minus x minus 2 over x squared plus 5x plus 4. So we need to factor the top and factor the bottom, and so we have x minus 2 times x plus 1 over x plus 4 times x plus 1. And so the x plus 1's cancel, and so we're left with x minus 2 over x plus 4. Now, if you struggle with factoring, you need to go back and watch the Capstone Lesson 3 on factoring again, and then come back and do this, because you'll need to be able to factor to be able to move through this pretty quickly. All right, to add or subtract fractions with the same denominator, simply add or subtract the numerators because you already have the same denominator. Watch out if you have to distribute a negative sign and express over the denominator. To add or subtract fractions with different denominators, first find the least common denominator for all the fractions, and you're going to have to factor to be able to do that, and then multiply each fraction, numerator and denominator, by the missing factors. Okay, so our first one, we've got 3x minus 4 over x squared minus 5 minus 3x squared minus 4x plus 2 over x squared minus 5. We have common denominators, so we can just write this as one big happy fraction, but we do have to be extra careful because we are subtracting. So when we do that, we can just write the 3x minus 4. But then if you're going to write the minus and not put parentheses around the second polynomial, you have to distribute the minus across that second polynomial. So you'd have minus 3x squared minus negative 4x, so plus 4x minus 2, so minus 2, all over x squared minus 5. So at this point, remember, you simplify the numerator. So let's see, that's going to be negative 3x squared, 3x plus 4x is 7x, and then minus 6 over x squared minus 5. And you always factor first if you can and see if you can cancel. So let's see, I can factor out a negative, but that's all I can do. If you do the AC method, you'll find that we can't factor 3x squared minus 7x plus 6, and x squared minus 5 can't be factored because 5's not a perfect square and there's not a common factor there. So our numerator and denominator are relatively prime, so we're done. All right, for example 3 part A, we've got 5x minus 2 over x plus 3 plus x squared minus 1 over 2x. We have different denominators, so we're going to have to find our least common denominator. Now these are fairly easy. X plus 3 is prime, and 2 times x is prime, and written as in factored form as 2 times x. By prime, I just meant it. We couldn't factor it any further. The factors are there and obvious. So our least common denominator is going to be 2x times x plus 3. All right, so the missing factor from the first denominator was 2x, and so we're going to multiply on top and bottom by 2x. The missing factor for the second fraction was x plus 3, so I'm going to multiply on top and bottom by x plus 3. And so that's going to give me 5x minus 2 times 2x plus x squared minus 1 times x plus 3, all over our common denominator. So now we need to simplify the numerator. So I'm going to distribute the 2x, and I'm going to FOIL out the x squared minus 1 times x plus 3. And then we'll have to add everything together, combine like terms. All right, so when I distribute the 2x, I'm going to get 10x squared minus 4x. When I FOIL, I'm going to get plus x cubed plus 3x squared minus x minus 3. So now let's write the numerator in standard form and combining like terms. So I'm going to have x cubed plus 10x squared plus 3x squared gives me 13x squared. Negative 4x minus x gives me negative 5x, and then minus 3. You look to see if you can factor it. We can't, and so the numerator and denominator are relatively prime to each other. All right, same process if you have numbers. You have to at least stop and consider the factors. We have 1 over 60 plus 1 over 80, and 60 is 3 times 20. 80 is 4 times 20. So let's see, 3 times 4 is 12, times 20 is 240. So our least common denominator is 240. So we're missing the factor of 4 for the 60. 60 times 4 is 240. So we're going to multiply on top and bottom by 4. We were missing the factor of 3 in the second denominator. 80 times 3 is 240. So we're going to multiply on top and bottom by 3. So we're going to have 4 over 240 plus 3 over 240. 4 plus 3 is 7. So we have 7 over 240, and those are relatively prime, so that's our answer. Okay, for part C, we've got 2 over x minus 2x over x minus 2 plus 4x squared over x minus 2 squared. So we have a single factor of x, a single factor of x minus 2, and a double factor of x minus 2. So our least common denominator is going to be x times x minus 2 squared. Okay, because this one has at least one factor, it's missing the factor of x and the second factor of x minus 2. So this would be our least common denominator. All right, so the 2 over x is missing both x minus 2 factors, so we're going to multiply on bottom by x minus 2 squared. So we have to multiply on top by x minus 2 squared. Then we have our minus. We have 2x over x minus 2, so it's missing the x factor and the second x minus 2 factor. So we multiply on top and bottom by x times x minus 2. And then our final fraction of 4x squared over x minus 2 quantity squared, we need to multiply on top and bottom by x because it's missing the x factor. So now we can write as one big happy fraction. So we've got our 2 times x minus 2 squared minus 2x times x minus 2 plus 4x squared times x all over x times x minus 2 squared. All right, so now this step is always simplify the numerator, and it usually involves some multiplication first and then combining like terms. So let's see. I have 2 times x minus 2 squared. The order of operations tells me to square the x minus 2 first, so that means I'm going to have the FOIL there. On the second term, this big thing is a term, I've got 2 times x and then times x minus 2, so I'm going to need to multiply. And then over here, I've got 4x squared times x, so I'm going to need to multiply there. So let's see, when I FOIL x minus 2 times x minus 2, or if I don't want to FOIL it, if I'm wise, I can look at that and go, oh, that's going to be a perfect square trinomial. So remember, you square the first, you square the last, you double the middle, and get out fast. So we have x squared, and then 2 squared is 4. Double the middle is going to be 2 times x, using the same sign, so minus 4x. Then I have minus 2x squared that I distribute over x minus 2, because negative 2x times x is negative 2x squared. So then times this x is negative 2x cubed. Negative 2x squared times negative 2 is going to give me plus 4x squared. And then finally my 4x squared times x is 4x cubed. I need to distribute this 2, and then I can combine terms. So I'm going to have 2x squared minus 8x plus 8 minus 2x cubed plus 4x squared plus 4x cubed. Let's see. So we need to combine terms. So negative 2x cubed plus 4x cubed is going to give me 2x cubed. 2x squared plus 4x squared is going to give me 6x squared. Negative 8x plus 8. So at this point I stop and I look to see if I can factor. I can bring out a 2. So I have 2 times x cubed plus 3x squared minus 4x plus 4. And I'm not going to be able to factor that any further. And so I'm done. If I can't factor, or, all I could factor out was the 2, there's nothing that's going to cancel. These two must be relatively prime, so we're done. All right, to multiply rational expressions, factor the numerators and denominators and cancel common factors set up here in the numerator and a denominator. Okay, multiply the remaining factors in the numerator together and the remaining factors in the denominators together, or just show them multiplied together. To divide rational expressions, one method involves first rewriting the problem as a multiplication problem, then factor the numerators and denominators and cancel common factors. And that's going to be the method that we use. Another method involves compound fractions. Fractions within a fraction, you find the least common denominator of all the denominators and multiply the numerator and the denominator of the compound fraction by the least common denominator. This results in the compound fraction becoming a simple rational expression. For the sake of the video, I'm going to stick with the first method. You're welcome to use either method, but I'm just going to stick to the first one when we get to some division problems. Okay, so for this example, we have a multiplication problem. We have 5x plus 6 over x minus 2 times x squared minus 4 over x plus 30. So we want to factor anything that can be factored, which in this case is just that difference of two squares. Everything else is prime. So we have x plus 2 times x minus 2. And remember, it's the all or nothing principle. You have to be able to cancel everything inside a set of parentheses with something else, or you just can't cancel anything. So x minus 2 cancels with x minus 2, and then we're left with 5x plus 6 times x plus 2 over x squared plus 30. Okay, so that's our final answer. All right, we've got x squared minus 4x plus 4 over x squared minus 25 divided by x squared plus 4x minus 12 divided by x minus 5. So let's rewrite this as a multiplication problem by flipping that second fraction. All right, now let's factor everything that we can factor. We have a perfect square trinomial that's x minus 2 squared. We have a difference of two squares, x plus 5 times x minus 5. And we have just a trinomial that we can factor. Let's see, numbers that multiply to give us negative 12 and add to be positive 4 or 6 and negative 2. I like to go ahead around a baby binomial like x minus 5, go ahead and put parentheses there just to remind myself that it's all or nothing, that the x minus 5 does cancel with the x minus 5 in the bottom over here in the first denominator because they do match up completely. Remember, this x minus 2 squared means that we really have x minus 2 times x minus 2, and one of those factors of x minus 2 will cancel with this factor of x minus 2 in the second denominator. And so we're left with just one factor of x minus 2 in the numerator over x plus 5 times x plus 6, and we'll leave it like that. We can drop the parentheses just to make it look a little nicer. Okay, 2a to the 4th b over ab squared all over 8a squared b squared over 2a cubed b to the 4th. This is a compound fraction because you have one fraction divided by another fraction. So the way we're going to work this today is we're just going to rewrite this as a division problem. So 24a to the 4th b over ab squared divided by 8a squared b squared over 2a cubed b to the 4th, because this is just another way of writing a division bar. It's just a division bar. You can write division like this. And I think it's just easier to go ahead and switch the forms and then continue to work the problem. Okay, so just like we did before, we're going to turn this into a multiplication problem by using the reciprocal of the second fraction. And so we'll have times 2a cubed b to the 4th over 8a squared b squared, just the reciprocal of what we had when it was written as a division problem. All right, we can go ahead, we can multiply across the top and across the bottom. So across the top we've got 48a to the 7th b to the 5th. Across the bottom we have 8a cubed b to the 4th, and then we just reduce. 48 divided by 8 is 6. a to the 7th divided by a to the 3rd is a to the 4th. a to the 5th divided by b to the 4th is b to the 1st. Let's just clean it up a little and write it as 6a to the 4th b, and we are done. Let's look at one more. Let's look at D. We have x cubed over x minus 3 divided by x squared minus x. All right, so this one might throw you off a little bit because you have a fraction divided by a polynomial, and that feels a little weird, but let's just do what we did with part C. Let's rewrite it with the big division bar. See how it's bigger than the other one? We're going to replace the big division bar with a division sign. So we're going to have x cubed over x minus 3 divided by x squared minus x. Now anytime you have a fraction of any sort and you're multiplying or dividing by something that's not a fraction, remember what you do to make it easier? That's right. You put the one that's not written as a fraction over 1 and then work from there. So this is the same thing as x cubed over x minus 3 divided by x squared minus x over 1. So I'm going to go ahead, I'm going to switch this to a multiplication problem by using the reciprocal of the second fraction. So I'm going to have x cubed over x minus 3 times 1 over x squared minus x. Alright, at this point I'm going to see if there's anything I can factor. Let's see. The x cubed, you can tell that's x times x times x. It's just a single base written to an exponent, so we're going to leave that alone. The x minus 3, we're just going to put parentheses around it. 1's about as simple as it can get. Let's see, x squared minus x, we can factor an x out. So we have x times x minus 1. Alright, so we have a single power of x on the bottom and an x cubed on top, so we can cancel 1 power of the x from the denominator and the numerator. So we'll have x squared over x minus 3 times 1 over x minus 1. Everything else is relatively prime, and so we have x squared over x minus 3 times x minus 1. And that is it. That is it for your Capstone Lesson 4. Thank you for watching the video and taking good notes. I look forward to seeing you in class, and I hope you have a great day.